demonstration, we're going to show how to extend the power of relativity to respond to subject access requests. Subject access requests under GDPR must be completed in 40 calendar days, so it's critical to find information responsive to the request and act on it quickly and completely. For this demonstration, we're going to focus on unstructured data, which represents significant challenges. In order to complete the request in a timely, cost-effective manner, we're going to use Heureka to help us to identify potentially responsive data across enterprise workstations and file shares, and move the search results to Relativity for review. Heureka's distributed architecture allows you to search thousands of machines at the file content level in minutes. For this subject access request, we're going to be looking for data for Nate Latessa, who's a former employee. The subject has provided his UK Nino ID and has asked what information we have that contains his private information. I'm going to start by creating a new search inside our search job called Subject Access Request. We're going to select the Sales, Marketing, and Finance workstations in our search criteria page. We do that by defining which endpoints we want our search to look across. Here we can look at our Finance department, our Marketing and Marketing file share, and our Sales and Sales file share. Next, we could use our query function to use the data that has been provided by Mr. Latessa, which includes his Nino address and his last name. We will then hit our search and search across all of our endpoints for that information. And now it will begin looking across 51 endpoints for both file metadata and content. As files are identified, the metadata results will be returned to the search grid. As you can see here, we have 5 endpoints that are still queued, 46 that are complete, 8 files that have been found so far. One more refresh shows that 51 endpoints are now completed. None are queued. Everything has been processed. You can see we have a total of 16 items. And you can notice inside our search results grid, hit highlighting that is occurring, as well as auto tagging that has been done by the Heureka classification engine. Once we are complete with this search and all the results are returned, we'll create a collection task which will create a load file for Relativity along with native files and text files. So we create our collection, give it a name, select which eDiscovery options we would like to use. We're going to look for all search results. We're going to create a .dat load file, and we're going to load our prefix and our numbering sequence into the system. We will now hit the collect button, and that will create a collection group on the left-hand side where collection will begin. With our collection complete and our documents now loaded into Relativity, we can begin the review process. So we switch over to Relativity, and here in Relativity we can see some of our documents have been coded already, but the top 2 documents have not been coded. So we're going to take a quick review of those documents. We've created a simple tag palette for non-responsive, responsive delete, responsive remediate, or responsive legal hold. On the right-hand side, you can see the Heureka palette and our tagging pane that has been created. As I review the documents, I can find the Nino ID and determine the appropriate tag. For example, if I scroll down to this particular second page document, we can find Nate Latessa and his Nino number. So we're going to go ahead and tag this file as responsive delete. We'll save that and move on to the next file. For this document, you can see that we have again Mr. Latessa's name, his Nino ID, so it's going to take on the responsive delete tag as well. We will now save that, and we're going to create an export file that will be imported back into Heureka to delete these files from their endpoints. Coming back to the main grid, we will then take all of the files that have been tagged as responsive delete, and we will export that information out to a CSV file. Now that I have my responsive delete list of hashes from Relativity, I'm going to create a new hash group and import my list into Heureka. So we slide back over into Heureka. You can see that we have created a search using those hash values and searching across the same endpoints that we did before. Looking at the search, we can easily verify that our dot count is the same, and we can also see that the system has the UK Nino tag in place. We can now create a file action for those files to delete them from each endpoint. We do that by selecting our file actions, selecting delete, and creating an action group. We now hit the delete button and we have a verification delete, which we can now proceed with and delete files from their endpoints.